With the permission of the Chancellor, I've decided to break tradition a little bit and show my own slides in this commemoration of Charlie Towns. Could we have the projector switched to my laptop? Now we need to go to my laptop, where I'll show a different picture of Charlie Towns. Okay, now we need to switch to the VGA. This worked beautifully earlier. Okay, excellent. So, it's a great honor for me to present this commemoration of Charles Hard Towns. Charlie, as he was known to everyone, was one of my personal and scientific heroes. He was a man of science and a man of faith, a Nobel laureate and a public servant, and for me, a teacher and a friend. He deeply changed both the science and technology of the 20th century. As the inventor of the maser and the laser, he introduced a device so ubiquitous to modern society that it's hard to imagine either scientific research or daily life without it. In astrophysics, he discovered the first triatomic molecules in deep space, and he found evidence for the black hole at the center of our galaxy. Charlie was born in Greenville, North Carolina. After finishing high school at the age of 15, he attended Furman University in his hometown, graduating in 1935. He got a master's degree from Duke University and a PhD from Caltech in 1939. He then joined the staff of Bell Labs, where he worked on the development of radar, a key technology for the Allies in World War II. That experience set the stage for his work on microwave spectroscopy of molecules, work that led to a 1955 book co-authored with Art Shallow entitled simply Microwave Spectroscopy. It was one of the first books that I studied when I began my research career when I went to university. In 1948, Charlie went to Columbia University and continued to work on microwaves. Searching for microwave sources working at ever higher frequencies, he developed the idea of the maser, an acronym for microwave amplification by stimulated emission of radiation. Among Charlie's key insights, which made the maser a reality, was a resonant cavity that stored and built up the stimulated microwave field. Famously, the idea for that came to him during an early morning outing while he was sitting on a bench in Washington, D.C. in 1951. And it was in that same year that he married Frances Brown. He's shown with her here sitting on a bench that was built many years later in his hometown to commemorate that inspirational moment, shown with his wife, Frances. And Charlie and his young colleagues reported operating the first ammonia maser in 1954, and here Charlie is shown with Jim Gordon in front of that maser. In 1958, a few years later, he and Art Shallow, who was also his brother-in-law, extended the idea of the maser to optical frequencies, coming up with the laser. And the idea there was that the gain medium was now inside the mirrors of a Fabry-Perot cavity. In 1960, the first laser was made by Ted Maiman, and in 1964, Towns shared the Nobel Prize in Physics with Basov and Prokhorov, who had independently come up with similar ideas. As the father of the laser, Towns's influence on science and technology cannot be overstated. Today, essentially everyone relies on lasers for a wide variety of applications that range from scientific research to communication, data storage, and transfer to medical procedures. After serving as an advisor to the US government for a few years, a role that he played a number of times in his career, Charlie moved to MIT as the provost, and it was there that he received the Nobel Prize. In 1967, he returned to basic research as a professor at the University of California at Berkeley, pursuing interests in radio astronomy and astrophysics. And I'm really impressed every time I think about how he changed the direction of his research in such a productive way at such a late time in his career. Now, at a time when most people thought that interstellar space contained only a few diatomic molecules at the most complicated, Charlie discovered ammonia and then water, which were the first triatomics discovered in deep space. He pioneered mid-infrared astronomical interferometry. He made the first heterodyne spectrometer. And in the 1980s, using precision spectroscopy techniques, he identified the black hole at the center of the Milky Way galaxy, a feature that had been predicted by Martin Rees earlier. Charlie's enthusiasm and hands-on approach to research never faded. Although he was officially retired in 1986, over 20 years later, in his 90s, he could be found, as you see in this photograph, preparing a telescope mirror for a night of observing by dusting off the surface perched on its mount. Charlie was also a pioneer in the connection between science and religion. He was an important mentor to me and to others interested in this subject. In 1964, at the famous Riverside Church in New York City, where he was a member, Charlie gave a talk that became a 1966 published article entitled "The Convergence of Science and Religion." This was a landmark in the science and religion field. I see it as the beginning of the modern study of science and religion, and its wide influence was a major factor in Charlie's receiving the 2005 Templeton Prize for progress toward research or discoveries about spiritual reality. He was the first, and I believe the only person, to have received both a Nobel Prize and a Templeton Prize. I spoke with Art Shallow, Charlie's collaborator on the invention of the laser, shortly before Art's death in 1999. And Art told me a little story about how someone had characterized another prominent physicist as the smartest person he knew. Art's response was, "Not while Charlie Towns is alive." Charlie died just 6 months before his 100th birthday, leaving us richer for all that he did.